All right, in this video we're going to look at determining the period of a sine or cosine function. So the graphs of sine and cosine are periodic in that the pattern is going to repeat itself indefinitely in both directions. So if we take a look at the graph of y equals sine of x, or we take a look at the graph of y equals cosine of x, here I have the graph of y equals cosine of x, notice the cosine is going to start at 1 when x is 0 and go down and come back up, and it just repeats that process forever to the left and forever to the right. So that's the idea behind periodic functions, is they have this part of the graph that just repeats itself forever in both directions, left and right. So we have here an example of the cosine function, but the sine function, as we saw, will have that exact same periodic behavior. So notice that the part of the graph in purple over here is a copy of the part of the graph in blue. Actually, I take that back. It's red. I changed it from purple because it was too hard to distinguish. But notice the copy in red here is a copy of the part in blue. And that's because our cosine function, like our sine function, is said to be periodic. So in terms of understanding what the period of a function actually means, here are some different ways you can think of the period of a graph of a function. One way is to look at how long it takes until the graph starts to repeat the same values in the same order. So in terms of the cosine graph, the values starting from 0 went from 1, then down to -1, and then back up to 1 again. And that is how long it takes the graph to repeat its values. Another way is, if you were looking at copying and pasting, what is the least amount of the graph you would need to copy to paste it before and after the copies? So you can just Control-C part of the graph and then Control-V the rest of it to the left and to the right. If the units along the x-axis are length, period would be the wavelength from science class. So in terms of what we're graphing the angle measurements. But if you're looking at things like sound waves in science class, usually you talk about the wavelength. That would be the distance between the crests of the wave, which for our purposes is the period of sine and cosine. So we can adjust the period of sine and cosine by multiplying our input values, our x's, by a positive number other than 1. Truthfully, we can also multiply by a negative. That's a reflection over the y-axis. We won't really see that too much, but it may pop up from time to time. So the equation for adjusting the period for sine and cosine is y equals sine times bx and y equals cosine of bx. I meant to say sine of b times x earlier. I apologize. So y equals sine of bx and y equals cosine of bx will adjust the period for our sine and cosine functions. In other words, they're horizontal stretches and compressions. So example 2, use a graphing utility to determine the period of each of the following. So we're going to start with y equals the sine of 2x. So let's take a look at the sine of 2x. So here's our sine wave for 2x. And I'm going to use the wavelength analogy and determine, okay, so we have a top of the relative maximum here at pi over 4 and another relative maximum at 5 pi over 4. So what's the angle distance between these 2 points, the pi over 4 and the 5 pi over 4? Well, if we take 5 pi over 4 and subtract 5, if we take 5 pi over 4 and subtract pi over 4, we get pi as the period of our function. Note that we don't have to use the maximums. We could use the minimums. I would avoid using the zeros because this is only half of the graph going from 0 to pi over 2. You'd have to complete another cycle. So you'd see it's one full wave goes from 0 to pi in terms of radians. All right, part B, we have cosine of 3x. So let's take a look at the cosine of 3x. So here's the cosine of 3x. Now with cosine, we can, again, use the maximums just like we do with sine. So we'll start with this maximum x value at x equals 0, and then all the way out to 2 pi over 3. So from 0 to 2 pi over 3, that's the period of this graph, is 2 pi over 3. Part C, we have sine of 1/2 x. So this is going to stretch our sine wave horizontally. So here we see the sine wave stretched horizontally. I'm going to have to zoom out for this one. But I could take the -3 pi here and the pi here, and then pi minus negative 3 pi, that distance is 4 pi. So our period of this graph is 4 pi. So again, by multiplying our input values by a number between 0 and 1, such as a half, it's going to stretch the graph horizontally away from the y-axis, which is going to increase what the period or the wavelength of this function is. And then we have part D, cosine of 1/4 x. So 1/4 is even closer to 0. This is going to be even more of a stretch, which means our period for this cosine graph in example D is going to be even larger than the 4 pi. So I'm probably going to have to zoom out. And yeah, I need to definitely zoom out here. So, okay, I got a maximum here and another maximum here. So from 0 to 8 pi, that length, that period is 8 pi. So we probably don't want to graph every single time and find the maximum points or minimum points and then calculate it from there. So if we look at what we've seen, the value that we're multiplying our inputs by, like a half or a fourth or a 3, has an impact on what the period's going to be. And it would seem that the different values of b are going to affect the graph in different ways. So in each case, our final answer for the period was whatever 2 pi divided by b was. So for instance, 2 pi divided by 3 was 2 pi over 3, for example B. 2 pi over 2, which is pi, was our answer from example A. 2 pi divided by a half is actually 4 pi, because 2 divided by a half is 4, for our answer for C. And then for D, 2 pi divided by 1/4 is actually 8 pi for answer D. So the period of the graph for sine and cosine is, if we are working with radians, it's 2 pi over whatever b is. If we're working in degrees, 2 pi is 360 degrees, is 360 degrees divided by whatever the value of b is. All right, so that about does it for this video. Thanks for watching. I'll see you